So you guys see my screen, right? Hmm. Can someone
Yeah,
confirm me on the chat,
yeah,
please?
yeah. It's advanced visualization in Jupyter notebooks. It's
Yes,
techniques.
yes, yes, yes. Good. Yep. So yeah. So uh, firstly, good morning or good afternoon, good evening or good nights from whichever time zone you are joining from the world. And thank you so much for taking time and attending my talk. I believe I'll definitely not waste your time and disappoint you guys. So today I'm going to talk about advanced visualization in Jupyter Notebooks. So in this talk, we are going to look at some advanced ways to visualize our data. Before we jump into the actual content, let me do a quick marketing about myself. I am Kalyan Prasad. I am a self-taught data scientist and analytics manager, and currently working with one of the startups companies in Hyderabad. And I also love involving in communities and try to help communities as possible as I can do from my end. And I'm currently board member and organizer of Hyderabad Python user group and PyConf Hyderabad chapter. And I also parallelly lead a planet lead at Humans for AI, where we promote diverse people from different technology, where we want to promote AI education in future. And my areas of interest currently lies in artificial intelligence and fintech. It's not just some buzzwords which are floating on the internet. It's something where the industries are transforming with these technologies and how industries are shaping with these technologies. That's why I'm quite passionate about these technologies. Uh, yeah, that's it about myself. And here is the agenda for today's talk. I tried writing in a simple Python function style. So we'll begin with an advanced visualization overview. Then we are going to give an introduction to information dense visualization. And then we are going to talk about visualizing data correlation. And following that, we are going to show a simple linear model by expressing the real world behavior of data. And followed by that, we'll be showing all these concepts practically with a real world with a practical use case study. And we'll wrap up the things what we have learned. So without any further delays, let's get started. So advanced visualization overview. Data visualization is a huge field. Now you can see that just by looking at various Matplotlib examples on their website. I'm sure most of you folks have at least visited once that Matplotlib website and you have seen this gallery. Just in case if you haven't visited Matplotlib, just go through the website and look at their gallery, how huge it is. Now, some of the key things to take away from this field without becoming an expert in data visualization are it's a huge field. So you have to be careful and not to exaggerate, even though you have so many tools at your disposal. Sometimes using less is more. Now, what does it mean by that? So sometimes using a simple method, doing a cleaner plot shows more information in a clearer way rather than going for fanciest of all tools. On the other hand, don't underestimate your audience. It is important to show various insights from our graphics. So we shouldn't just assume that the average reader of our document or a person who is going to look at our analysis report won't be able to understand the concepts we are describing. Instead, we should try to teach the audience how to read the more advanced charts and don't underestimate them. I like to think visualization as a way of storytelling. So think about what the motivation of your research or work is, and basically how to use these plots to guide the reader to understand the concepts you have discovered in your data analysis. Introduction to information dense visualization. A key person in data visualization theory is Edward Tufte. He has really mastered the skills and written multiple books on the same matter. I would highly recommend if you can read his book, The Visual Display of Quantitative Information, which is the prime source that really combined all of the important concepts in this talk. The important concepts he mentioned in his book is called information density. So think of this way. If we have a pie chart like this, which basically shows the size of four items. So wouldn't it be better if we just replace this pie chart by four numbers? Because the pie chart uses a lot of colors, a lot of shadows, a lot of effects here. At the end, the information it just covers is about the numbers. So maybe it would have been better to use a table in this case or just describe the number in text. One of the graphic tools used in his book is called Napoleon's March, which was created by Charles Joseph Minard. So this graph basically shows the Napoleon's army losses in the Russian campaign of 1812. This graph looks a bit complex at first sight, but don't get panic. But if we break down this graph, the brown color shows the size of the army and the position of the army as it advanced towards Moscow. And if we look at x-axis, it shows both the geographical movement and the passage of time. The black color shows the retreat of the army after their loss. And we can see many variables on this graph. This is called multivariate visualization. We can see the army size, its location over time. And on the small graph here on the bottom, if you look at the temperature that related to army's retreat, where you can see the temperature is really getting close towards the end of retreat phase. So this is an example of information dense visualization, which shows many aspects and basically tells a story in and of itself, which makes it a masterpiece of data visualization. Now, you might be wondering what sort of graphics we are going to look at. I'll be quickly showing you in a while once we cover the remaining concepts. So, yeah, I mean, like once the presentation is over, you can go to get into the detail and you can observe the graph what I have so far discussed on this point. And next we have is visual data correlation. The main objective of this concept is to compare different methods of a two data variables. We are talking about time series data. The first thing would be the visual comparison and better to understand the properties that we can compare. So let's see what time series is and what sort of patterns we can compare from it. So here is an example of a sample time series. Here you can see the first plot. This is the original. And if you look at the second plot here, where we can already see the seasonal effect or the seasonality. For example, imagine a temperature changes during a year changes from spring to winter or a summer, etc. So these are certain patterns and we call these patterns if they are repeating over time. And then what we have is called the trend line, which is a third plot in our visualization. So trends can be changes or trend can be long-term changes over time. So what I want to finally conclude here is if you are plotting time series side by side, one way is to look at these properties like seasonality trend, then we can compare it. The method which we are going to show, which basically describes the trend more clearly, is known as a moving average method, which I'll be showing you in the Jupyter notebook. And the second plot, which has the similarities between the data and the relationship, is called a scatter plot, which basically plot two variables, one on each axis. So here is an example of a scatter plot of income and education. And the data point shows for each data point, a person with particular education length in years and what their income is. The scatter plot, what shows here is called a correlation. So correlation is a significant measure of association or dependence. So without going into much details about it, which goes beyond the scope of the talk, you can think of correlation visually. So a perfect correlation of one would be the linear function, which is the first example in our plot. And if you look at the correlation with zero point 0.8 here, we can see a scatter plot where we can also see some sort of direction. There are certain messy points here. There is a lot of variance, outliers, and so on. And if we jump to the example of correlation 0 here, we can see a circle of messy points here. And it clearly says that there is no relationship between variables. One thing that usually mentioned in relation to correlation is correlation does not imply causation. It means if two variables are correlated each other, it doesn't mean that one affects the other. So it is important to understand the data and the factors that affect it. Maybe there will be a common cause and so on. This is a huge field of a study. So we are going to look at a simplified overview of what exactly a correlation is. Then followed by finally what we have is called linear regression. So in this thing, we are going to look at how to use a linear regression. So what is linear regression? It is a method for fitting a simple mathematical model to our data. The function which we are going to use to fit our model is called simple linear one, which is f of x is equal to ax plus b. So if we show this graphically, it looks as it describes our data behavior by plotting a straight line that basically follows the direction of a scatter plot. So this is a simple example, but it would be a typical use case we use in science, which is to model real world behavior on experimental data. So we collect the data. In reality, we collect the data and we try to model it to describe it. We use some mathematical functions, we compare the result, we evaluate the errors and so on. This is actually a beginning of a actually doing the science of, I mean, this is actually a beginning step of actually doing the science of a data science part. Now, so far you have been listened a lot of a theory about visualized correlation, linear model, information dense visualization. Now let's get into some action. So what we are doing is we are going to take these two data sets, which is like crime data and weather data from Chicago website, and we'll analyze these two data sets in relation to each other, and we'll show our graphic based on this data set, and finally we'll build our linear model on the same. So let me quickly jump to my Jupyter notebook here. Mm, yeah. So I hope you see my Jupyter notebook, right? Yes.
Yes, yes, it's okay.
Yeah. Yeah. Thank you so much. Okay. So as usual, we'll impact necessary suspects here. So we'll import our necessary libraries. Then we are reading both data sets here. So one thing I would like to mention here is I have gone through the CSV file of a crimes data where I have noticed that that data was so uncertain and unordered. So what I have done is I have made some adjustment while passing this data. So I have written this piece of a code while passing this data. So basically what I have done is I have selected only the 2016 period data and thrown away the rest of data due to the memory constraint because the data is quite huge. So after doing all this partition, so I got a final data frame for the crime CSV for the 2016 period data. So likewise, I have also read the weather data where I have selected the period as 2016. So the both data set will be on the same period. Now we are plotting the data side by side. So from weather data, what I've selected is temperature column and resampling it by day and giving an aggregation function mean. And once we plot this, we can already see the seasonal effect that we would expect from weather data. So it gradually looks like hotter over summer or cooler over winter. So the same way I've also done for primes where I've selected the prime type as a column and sorry, resample it by day and doing a count. I mean, the aggregation function as count. Once we plot this, we can see the number of crime instances. So one important point which you have to remember is you can select any type of a column. So for this demonstration, I have selected because my analysis was based on this column. But again, you can select any column according to your analysis. So there is no such restriction that you have to select only particular column for this. So to simplify these variables, what I have done is I have created two variables called daily temperature and daily crimes, where I have passed the same function what I have shown above. Now we are plotting them on the same graph. So once we plot this, now you can see that these two are different data types and the values are nowhere close to each other. So if you look at the crime values are somewhere in the range of a 10 to 20, whereas the temperature values are somewhere in the range of a 10 to 20, whereas the crime values are in the range of a 600 to 800. Now this is the problem. So what shall we do in this case? In theory, we could have added another y-axis by plotting the same graph on the same plot by adding additional y-axis. But that is generally considered to be a bad practice in data visualization. Instead, what we could do is we could create a two subfigures here. This we can do with a matplotlib. So what I have done is I have created two subfigures here, and I have also given some additional matplotlib properties like a title, fixed size, and x label, y label. Once we plot this, now we can clearly see that which data set belongs to which graph. So this is the temperature and this is the crimes. Now we can clearly conclude that temperature and crime are one next to each other. And there was a point which I mentioned in the slide here. We are trying our time series curve to smoothen. So this can be done through a rolling function. In pandas we have a rolling function. So what we are doing is we are calling a moving average method on this crime data, and we are doing aggregation on this one. So once we plot this a certain points of this crime data, an average will be calculated. So the more you increase the number, the more the curve will be smoothened. So you can play around and check it out later. So here I'm giving us a 10, but later you can check it by increasing the rolling method. Now I'll understand how smoothing the curve will be. And of course, we can also expand our analysis by doing with some interactive widgets through a IPython widget. So what I have done is I have imported the IPython widgets through interactive, where I have given some minimum, maximum, and step value here. And what I have done is I'm doing calculating the same moving average method, which I have shown above, and some additional properties here. So once we plot this, now you can clearly see that how the curves are so smooth for both time series. So here I've selected the period, but you can probably play around and observe and understand how the curve looks if you decrease the period and all. By looking at this now, it can clearly says that there are similarities between the temperature and crime rates data. So to better express this, we can calculate, we can use a correlation and a scatter plot as I described earlier in my slides. So to do this, what I have selected is I have selected these two time series data and pass it to this data frame. And now we are giving a separate column, one for crime and one for temperature. So once we execute this, now you can clearly see that we got a new data frame. At least this is a beginning step for our data analysis to explore further on the process. So now if we call the plot method here, we get a default time series plot. But instead what I've done is instead of giving a default time series plot, I have given kind of a scatter, and I also provided the X as temporary X label and Y label. Now once we plot this, we can see a clear scatter plot here. And if you observe here, if for a certain temperature on the exact same day, so what would be the crime rate here? So, and you can also observe the lower the temperature, the lower the crime rates are. The higher the temperature, the higher the crime rates are. So there is some sort of a correlation definitely happening in this case. And if you want to witness this through statistically, if you want to witness this to statistically, we can use this through a core function. So here by default, I have used the Pearson correlation function, but probably you can do with a different correlation function by looking at the documentation. So I have used my code function on my data frame. Here my correlation is 0.73. So if you remember, I have shown you a correlation value of a, so this shows the correlation value which you have seen in slides, that how the data was correlated from 0 to 1. I mean, if you remember, which I have shown in your slides. And if you get back to storytelling side, if you one thing that usually pops in my mind, at least for me, is that there is an outlier. So outliers are definitely leads to an interesting stories. So if we see the most of the data is clustered in this big area, suddenly there is a huge outlier at this point. So what I have done is I've selected this particular outlier to know the reason behind it. So what I have done is I've selected my data frame and crime greater than 1000 data points because it was greater than 1000. So what I've done is I've selected that. So once we execute this, you'll see the results as it's something on January 1st. So the theft may be happening due to because of large gatherings and large crowds. And but again, this is just a 1 year data, but it's good to analyze the other data, other years data before we make a final decision here. But one thing I want to make you understand here is it's good to look at the outliers, good to look at this graph and kind of a thing to understand the outliers and try to know the reason behind the stories of the outliers, because outliers are definitely leads to an interesting story which will definitely help you improve your model accuracy and your data analysis process. And finally, what we have is we are building a simple linear model here on the same data. So what I have done is I imported the stat model API, which is a Python package for performing some statistical function. And followed by that, I have also included the AB line plot, which we use for graphics. Uh, So what I'm doing is here I am passing my data frame. So we have only one constant variable here. So what we are doing is we are going to calculate the crime rate based on the temperature. So our input value is the temperature, and based on the temperature, we are going to estimate our crime rate. So what I'm doing is I'm calling my model.fit function. So once we execute this, we'll get the model result parameters. So we model results or objects that has some parameters like A and B, and our model result summary. So we have a different statistical summaries here like R square, adjusted square, standard error coefficient, T, P values and all. Again, I'm not going into in detail about all of these concepts, but I would highly recommend that you please keep a tab on all these things while you are doing a data analysis, because this will definitely improve your model accuracy and help to get help your model accuracy and get a good results on this. So right now we are just sticking to our surface layer here. So what I'm doing is, I'm just creating a new value, passing a new input value. So based on that new input value, we are going to get some output of our model. So let's say the case is like, let's say that tomorrow weather forecast is going to be 28 degrees average. So how much crime rate can we expect? Or during the winter temperature, it's going to be 5 Celsius. So what would be the crime rate then? So with the help of the predict method where I'm passing this series, once we execute this, we got some output results here. And again, of course, taking such predictions with definitely grain of salt, because if you remember, our scatter plot has a lot of variance and outliers in our data. And moreover, we are just investigating only on the 1 year of data. But the reason behind for all this explanation is to give you a quick preview of how can you, what kind of, I mean, like what kind of how can you deal with the different kinds of situation like these kind of a linear models. So to give you such preview, so you need to understand this kind of scenarios. And again, is there a way where we can also plot this if thing? I mean, like, of course, we can plot this as we have done before. So firstly, we are plotting the scatter plot as we have shown above, and then followed by I'm calling my AB line plot method, where I'm passing my model results object, where I'm also giving some axis values and the labels and other matplotlib properties. So once I execute this, you can see a scatter plot as we have done before, as we have shown before, and it also shows a line which is obtained through linear function through our linear model. So I think it is a nice implementation graphic here. So it shows multiple information types. So we have two data sets that we have passed to get this graphic, and it also shows our model on top of our data, which has a multiple layers. So I think it is a nice implementation of a mantra of doing a information dense visualization techniques. Uh, so uh, so to wrap up the things, what we have seen so far, so we have explored the different information dense visualization techniques, and we have also seen the different aligned time series plots and scatter plots where we have understood about the properties of time series plot, how to compare, and we have also seen different scatter plots like how to plot the two variables, one on each axis, and we have also discussed a method of called moving average, how we with that method how the we can smoothen our curve. And finally, we have shown a simple model by expressing the real world behavior of data. And yeah, that's it. Though these are the quick references which I have used for understanding these concepts. And yeah, that's it. Thank you. And I'm open to take questions if you have any. Sorry, pardon if I was a bit fast in explanation, but you can ask me if you have anything. I'll be happy to answer if you have any questions.
Hello there. Actually, I'm wondering about the slide where you just displayed the issue of,
Orange street lights.
of getting. Hello.
Yeah, please.
Where you got the scale of the two drawings and the package used in this.
Which one you mean? Which one? Just let me,
The scale
just
period
let,
space.
just let
Yeah,
me share the screen.
yeah.
This one?
No. It's in the Jupyter notebook where you just displayed the scale of time span in terms of number of days. I just
This one?
two subplots in the Jupyter notebook.
Yeah. This one? Yeah. This one?
Actually, the one that displays now is the one of Charles Joseph Maynard, Napoleon's March.
Yeah.
Not the,
Yes.
I am referring to the Jupyter notebook.
Yeah. This is the Jupyter notebook. Do you see my Jupyter notebook?
No. I think there's something with the screen shared.
Wait. Let me share my screen again.
Okay.
Is this one you're talking about?
No, the later. You just go. Yes, this one.
This one?
The one
This
above
one?
this. Yes, this one.
This one?
I need just. Import interact.
Yeah, import interact widget. So it's a IPython widget. So what you done is you can interact with this data. You can play
Okay.
with this period. Yeah.
Okay, it's really interesting actually. Thank you
Yeah,
for this.
yeah. Anyways, I'll share you the notebook. Probably you can play with it, and you
Yeah,
can
thank you.
experiment with your data.
It would be highly appreciated actually.
Yeah. So the main
Thank you, sir.
objective of this is to, when you have a multiple data or different data, so you can plot both on the same graph and to understand the correlation and how you can build on top of model for these different kinds
Uh,
of situations, for these situations
uh,
of these cases.
and you and playing around and unifying the time spent is really interesting actually. It's a really
Yep,
interesting tool.
yep.
Thank you for that.
Yeah, no problem. Uh,
Good.
yeah. Any other questions? Less is more. Yes, less is more most of the time. True, Carol. Um, mm, yeah. Any other questions if you have? Yeah, maybe you can ask me anything. Maybe not related to this thing, or else anything related to data science, something like that.
If I were to ask something about is the catch 22 of math, calculus, and linear algebra and its relation or يعني its use in data science. How do you
Mhm.
perceive this?
So, I mean, you need to have some basic idea about, I mean, the basic school standard mathematics, like in the class of eighth or something like that. So you need to have some basic idea about calculus and linear algebra, but it is not mandatory that for you to learn or explore data science or something on machine learning. uh, the more you do some practical hands-on, or the more you explore doing real time, that's how you learn different mathematical concepts. But you cannot learn everything in a day or in a month, but it's an iterative process. The more you explore, the more you dig into model understanding, or the the scenes behind the algorithms. So that's how you will get to know more about the mathematics, especially the calculus and linear algebra.
Okay, it's fair enough. Actually, as a challenge with me here, with this point, يعني for me especially is of just retaining the information of all the calculus and all the linear algebra across years and just getting them to be put again into data science context. So that's the point for this question. Thank you
Mm.
for the explanation, actually.
Yeah, welcome. Yep. So, any other questions? Yeah. If you have any questions, please type in chat, or else you can unmute yourself and ask me. Yeah, folks, any questions?